Alright, so we have to draw a k-ary tree where k equals 4 after insertion of the following elements in order. So we got k equals 4, and the elements we got 5, 4, 6, 8, 2, 9, 10, and 1. So k equaling 4, so it means each node should have 4 possible children unless they run out of elements. So, gotta go in order. So we got 4, 6, 8, and 2. And then we go down to 4. Since there's only 3, we stop at 3. So then we got 9, 10, and 1. Alright, so question 2, part 1. So looking at the tree, we have drawn how many leaves and nodes are present. So leaves are nodes that have no children. So we have 1, 2, 3, 4, 5, 6. 6 leaves. So we got 6 leaves. And nodes are just all of them put together. So every element. So we got 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 nodes. Question 3 of part 1. So examine your tree and find both the root and the node with the value 4. For both nodes, list the following attributes: depth, height of subtrees, number of siblings, and number of children. So we're looking at 5 and 4. So put 5 and 4 here. And this one will be the depth. So since 5 is the root, it has a depth of 0. And since 4 is a child of 5, it has a depth of just 1, since it branches off to 4 right here. Then we have 5 and 4 again. And that we have the height of the subtrees. So for the height of the subtrees, we have, for the first one for 5, since it's all this, counts for just this side. So we have 2. We have 1 here for the one branch. We have another one right here. And we also have 5 and 2, which is just 1. And for 4, they're all 1, but there's only 3 children. So we have 1, 1, 1, and 0. So now we have nodes 4 and 5 again. And we are doing number of siblings. So 5 is the root node, so it doesn't have any siblings, so it's 0. And 4 is right here, so it has 3 siblings, 6, 8, and 2. And the final one is number of children. So 5 has 4 total children. So 4, 6, 8, and 2. So just put 4. And then 4 has 3 total children, which is 9, 10, and 1. So question 4 of number 1. So we have to insert 6 more random elements into your tree and relist any of the above attributes that have changed. So what we're doing is doing the same thing for this question, but we're adding 6 more random elements. So we'll have the same elements that we had before. Make some space. So we got 4, 6, 8, 2. So we got 9, 10, 1. So we'll just add, say 7, 1, 2, 3, 4. So this is the first one. So then we got 13, 21, 31, 55. So that's 5, and we'll add 1 more. So we'll add 89 right here. So right here. So then we'll go back to the same thing that we did up here. So we'll do nodes 5 and 4. And the depth is the same. So we got 0 and 1, since it's 1 right here. Then we have the height of the subtrees. So we got 5, 4. So then we have 1, 2. So we got 2 here. Then we got another 2 here. Then we got another 2. And then we got a 1. Since it still only has 1 for 2. And then 4. We have 1, 1, 1, and 1, since all the children are filled. And then next we got number of siblings. This doesn't change for either. So 5 still has 0 since it's the root, and 4 still has 3. And then we have number of children. So 5 is still the same with 4 children, and 4 now has 4 children, which we added right here. So question 5 of the part 1 is, would the structure of the K-array tree you drawn change at all if the elements were inserted in a sorted order? Explain why or why not. The answer is no, because no matter what, K will always equal 4, so you just follow down the list of elements. So say if it was 1, 2, 3, 4, 5, 6, 7, 8, you just have 1, 2, 3, 4, 5, 6, 7, 8. The structure would be exactly the same even though the numbers are in order. So because we are inserting the elements independent from what the actual values they are.